All right, we're going to go ahead and get started with Chemical Reactions Podcast 3, where you're going to learn to identify different types of chemical reactions. I have 6 reactions that I'm going to go through in this podcast, and I'm going to go through each one individually. So you can either pause the podcast and jot all of this down, including the schematics, or you can get the schematics as I go through each individual podcast. The first reaction we're going to start off with is a synthesis reaction, also known as a combination reaction. Now, your Georgia Standards of Excellence explicitly refer to this as a synthesis reaction, so that is the term that I will use in this course. As the name implies, this type of reaction is when 2 or more elements or simple molecules come together and form a more complex substance. You can see this in the schematic as well. And on a side note, these reactions are usually exothermic, so they usually release energy to the environment. Let's go ahead and get an example here. Now, throughout this podcast, if you would like to pause the podcast and attempt these on your own, that is what I would encourage you to do. And then I'll work through each one individually as well. So in this first one here, we have solid barium combines with chlorine gas. Now that's a Brinkelhoff, and it's going to form a more complex substance, and that substance is barium chloride. Now remember, barium is a +2 charge. It's a group 2 metal, and chlorine is a halogen that carries a -1 charge. So to make those charges 0, I'm going to have to add 2 chlorines to the binary structure of this compound. All right, so and as you go through and look at it, you can see, hey, it's already balanced. So we're all done with that one. In our next one here, we have sulfur trioxide gas combines with liquid water to form sulfuric acid. 8 is ich, 8 is aus, and you know a polyatomic that ends in 8, that is sulfate. Now sulfate has a -2 charge. Each hydrogen is a +1, so the correct structure here would be H2SO4, and all acids are aqueous. I want to make a side note over here. A lot of students ask me, say, well, isn't that sulfite? No, this is not sulfite. Sulfite is a polyatomic ion that will readily form an ionic compound. It carries a -2 charge. This is a molecular compound composed of 2 nonmetals, and so you're going to use your Greek prefixes when you're naming this. So this is sulfur trioxide gas. Okay. Our next type of reaction is a decomposition reaction, and as the name implies, this is a reaction where a complex substance breaks into 2 or more simpler elements or substances. These are typically endothermic, which means they're going to absorb energy from their environment. Our example here, we have solid barium hydroxide. Hydroxide is a polyatomic ion with a charge of -1. Decomposes into solid barium oxide plus water. And at 25 degrees Celsius, water would be in a liquid form. And if you go through and look at this one carefully, you're going to see, because we have 2 hydrogen here, 2 oxygen here, we have 1, 2 oxygen, and of course 2 hydrogen as well. Our next example here, we have solid iron 3 sulfate. So in order to make those charges equal to 0, the 3 is the charge of the iron. So we're going to have 2 of those. Sulfate -2, so it's going to take 3 of those. And this is going to break down into solid iron 3 oxide and gaseous sulfur trioxide. 1 iron here, or excuse me, 2 iron, 2 iron, 3 sulfur. Let me try to put a coefficient of 3 in front of the sulfur trioxide, and we'll see if that works out. And we have 12 oxygen here, and on the product side we have 9 plus 3, so we have 12 there, and we are all balanced and ready to move on to our next reaction type. Okay. This is my personal favorite. Your teacher has a proclivity for fire and combustion reactions and explosions. I'm a bit of a pyromaniac, so we talk about these a lot in class, and we have several demonstrations I'll be doing for you guys in class as well. And you probably already have a good idea about these from previous podcasts. These involve a CHO or a CHA, so these compounds involve a CHO or a CHA. More accurately, we'll call those hydrocarbons. And they combine with diatomic oxygen, and they always yield the same products: oxygen gas, carbon dioxide gas, and water. This being a reactant. Product. Always carbon dioxide and water for your products. All right, so let's look at this one here, octane. I've chosen this one because this is like gasoline for your lawnmower, for your car, whatever. So let's go ahead and look at this one here. Plus oxygen. Now, if you're wondering, did he ever teach me nomenclature here? No. You'll get a feel for it as we go through the course. You'll learn quite a bit about it. But you're not required to just know the formula for octane. Combines with, and this is actually in a liquid form, combines with gaseous oxygen and will yield carbon dioxide gas plus H2O gas, because this is going to occur at a high temperature. This is an explosion, highly exothermic, giving off a tremendous amount of energy. All right, let's balance this. Start with your carbons. 8. I'm going to try to put an 8 here. Next, moving on to the hydrogens. 18. Okay, 18 here. Let me try to put a 9 here. Worst case scenario, I'll do the CHO2 rule or erase it or try again. And I do want to reemphasize the fact that many students that hit a wall with balancing and say, I just can't get it to work, it typically is because there's something wrong with your nomenclature. So if you're spending too much time trying to balance, I highly recommend you go back and make sure each of your formulas are accurate and correct as well. Okay, so back to balancing. 18, oxygen. We have 2 here. We have 9 plus we have 16. We have 25. How are we going to make this an odd number, 25? We can't. So we're going to go through and do the CHO2 rule. So here we go. 2. I'm going to double my carbons. I'm going to come back over here, cross that out. Double that. Come over here, cross that out. Double that. And by doubling that, that means I need now 50 oxygen. And by placing a coefficient of 25 here, 25, in case you're not seeing that, I can get this reaction to work out well. Okay, and in case you're not seeing this 18, because my face is blocking it, I'll write it again right there. All right, so now we're balanced. The combustion of octane to yield the same 2 products every time, carbon dioxide and water. Okay, in our next type of reaction, this is a single replacement reaction. In these reactions, a compound and an element switch places with each other. So an element will come in and essentially kick out or supplant the other cation, positive species in the diatomic, or excuse me, in the binary molecule. All right, so let's look at one. It's easier to look at one than try to really put it in words sometimes. So solid potassium, group 1 metal, is mixed with aqueous copper 2 nitrate, aqueous, and it is going to yield to form aqueous potassium nitrate and copper. Let's balance this. 1, 1, 2. Okay, I need a coefficient of 2 here, which gives me now 2 potassium, which means I need to come over to the reactant side and put a coefficient of 2 there, and we are all balanced and all set here. Our next reaction is a double replacement reaction. Some textbooks, some professors refer to it as a double displacement. We will call it a double replacement reaction. And this is when you have two compounds that trade cations or anions with one another. Both of the products, or excuse me, both of the reactants are going to be aqueous, and they're going to yield a solid precipitate. And we'll learn that there's exceptions to that as well in the upcoming podcast, but for now, that would be accurate to say two aqueous compounds combine, forming one solid precipitate and the other typically being aqueous, although there's exceptions. So let's take a look at this reaction here. This is really cool, and you're going to get to do this in class if we haven't already done it, where we're combining aqueous lead 2 nitrate. All right, so let me go ahead. Lead 2 nitrate, aqueous, remember both reactants are aqueous, is mixed with aqueous potassium iodide. And that is going to yield. So what we're going to see here is this is going to come in here. This guy's going to come over here. And it's analogous to two couples dancing and they switch partners. That's exactly what's happening here. So we're going to yield potassium, or excuse me, lead 2 iodide. This is a solid precipitate. This is what you see in the video. That is yellow. So cool. And the other product is going to be, I'm going to write it here so I don't end up blocking it with my face here, is going to be potassium nitrate, which is aqueous. All right, let's go ahead and balance. We have one lead. We have, or should, if I didn't do that, 2 nitrates with lead 2 nitrate. And so I'm going to put a coefficient of 2 here, 2 iodine. Let me go ahead and put a coefficient of 2 in front of the potassium iodide, and 2 potassium, 2 potassium, 2 nitrate, 1 lead, 2 iodine, and we are balanced. Okay, in this final type of reaction, which is really just a special type of double replacement reaction, but I want to take some time and look at it separately, is a neutralization reaction where you're combining an acid and a base. When this occurs, the products are always going to be a salt and water. Now remember, our definition for salt in chemistry is an ionic compound which is composed of a metal and a nonmetal. Okay, but these products are always going to be the same here. Let's look at this example here. Hydrofluoric acid, hydrofluoric. When there's the hydro and the ic, that's going to be the ones that end in "ide." So I'm going to say, if I named this, if this was a gas, let's say, I would call it hydrogen fluoride in its aqueous form. It is a strong acid called hydrofluoric acid. It is combined with a strong base, sodium hydroxide. We probably already used this one in lab. We will never use that one in lab. And that's going to give me salt water. Okay, what's my salt? Well, remember, it's the ionic compound. It's going to be sodium fluoride in this case. and that's aqueous, and water, H2O liquid. Let's balance 1, 1, 1. Let's look at our, let's see, we have 2 here, so I'm going to go ahead and, wait a minute, we have 1 here, so we are all balanced and all set on this particular reaction. And in this reaction here, we have another strong acid that is going to be nitric acid. And all acids are aqueous, and it is mixed with calcium hydroxide, a group 2 strong base, and we're going to get salt water. And our salt in this case is going to be calcium nitrate, and aqueous plus water. Okay, 1 hydrogen. Well, let's start with our polyatomics. I have 2 here. I want to keep the family together, so I'm going to put a 2 right there. And then coming across calcium, there's 1 calcium, 1 calcium. Let's look at our hydrogens. We have 2 plus 2, which gives me 4. So I'm going to place a coefficient of 2 in front of here, and that's going to end up working out just fine for us here. Everything's going to balance out on this final reaction. Again, this is aqueous, and we are all set with this podcast, and you were learned in this podcast how to identify types of chemical reactions. So now you can go through and finish that problem set 1 through 3 and identify all the reactions that you've hopefully already written out and balanced. Thank you.